There is a moment that every human being has faced or will face when standing beside someone they love who has just taken their final breath. In that moment, something feels irreversibly gone. The person who was there, who existed, who breathed and thought and remembered, seems to have been erased from the universe entirely. That feeling is one of the most profound and painful experiences of being alive. And yet, if you follow the mathematics of Einstein's theory of relativity to its logical conclusion, that feeling, as real and as devastating as it is, may be describing something that the universe itself does not recognize. It may be describing a concept that the deepest laws of physics do not actually contain. That is not a comforting platitude. That is not wishful thinking dressed in scientific language. That is what the equations say. And the path that leads us there begins not with death, but with the way we think about time itself. We all carry around an assumption so deeply embedded in our intuition that we rarely even notice it. We assume that time flows. We assume there is a moving edge called the present, a razor-thin slice called now, and that this edge sweeps forward from the past into the future, and that what lies behind it is gone, fixed, sealed. The past is over. The future has not yet happened, and the present is all that genuinely exists. This picture is so natural, so effortless to believe, that it seems almost absurd to question it. It matches everything we feel in our daily lives. The coffee cools, the leaves fall, we age, time moves forward, the past disappears. But Einstein showed us with a precision that has been confirmed by experiment after experiment for over a century that this picture is simply wrong, not approximately wrong. Not wrong in some exotic, extreme condition that has no bearing on ordinary life, wrong in a way that is woven into the fabric of space and time at the most fundamental level. Here is where we need to think carefully, and the best way to do that is through the kind of thought experiment that Einstein himself loved. Imagine you are standing on a train platform, completely still, watching a train go by at an enormous speed. On that train, a passenger is sitting quietly in the middle of a car, and at the front and back of the car, there are two light bulbs. At the exact moment that the passenger passes you on the platform, both bulbs flash simultaneously, or so it appears to the passenger, because the light from both bulbs reaches the passenger at the same moment. And since she is equidistant from both ends, she concludes the flashes happened at the same time. But what do you see standing on the platform? You also see the light from both bulbs, but the train is moving, which means the back of the car is moving toward the point where the flash originated, and the front of the car is moving away from it. From your perspective, the light from the back bulb has less distance to travel to reach the passenger, and the light from the front bulb has more. The speed of light is the same for both of you, and this is the crucial point. The speed of light does not change depending on who is measuring it. So for you, the two flashes cannot have happened at the same time. The back bulb must have flashed later to give its light time to catch up. Two observers, both perfectly rational, both using the correct laws of physics, disagree about whether two events are simultaneous. This is not a perceptual illusion. This is not a trick of measurement. This is what the universe actually is. Simultaneity is not absolute. What counts as now is not a feature of the universe that everyone shares. It is a feature of your state of motion. And here is where the ground begins to shift beneath our feet, because if now is relative, if different observers moving at different velocities will disagree about which events are happening at the same moment, then the very idea of the present as a universal, objective edge that divides what exists from what does not exist begins to dissolve. The universe does not have a single shared moving present. The universe does not have a single now. What it does have, and this is the picture that emerges from relativity with extraordinary mathematical clarity, is all moments. Past, present, and future, all equally real, all equally existent. What changes between observers is only which slice of this structure they call now. But the entire structure, the entire four-dimensional landscape of events, exists in a way that is complete, in a way that does not change, in a way that does not sweep forward. The physicist and philosopher Hermann Minkowski, who was one of Einstein's former teachers, put it beautifully when he said that Space by itself and time by itself are doomed to fade away into mere shadows, and only a kind of union of the two will preserve an independent reality. What Minkowski saw is that what we call space and what we call time are not two separate things. They are two aspects of a single, unified structure. Space-time. And space-time is not a stage on which events happen and then vanish. Space-time is a block, a four-dimensional loaf, if you like, in which every event, every moment, every location exists as a fixed coordinate. Physicists call this the block universe. And it is not a fringe idea or a philosophical speculation. It is the direct geometrical implication of special relativity. When you draw the mathematics out carefully, when you trace what the Lorentz transformations actually mean for the structure of reality, you arrive at a picture in which the past is not gone. It is there, fixed, as real as anything you are experiencing right now, and the future is not waiting to be created. It is there too, already laid out, already part of the structure of what exists. Now, before we go further, we need to sit with what this actually means, because there is a version of this idea that sounds like mystical hand-waving, and there is a version that is hard, cold physics. The hard, cold physics version says this: if you take any event in your life, any moment that you experienced, the moment you learned to ride a bicycle as a child, the moment you held someone's hand in a hospital room, the moment you watched the sun rise over a mountain, that moment is not gone. It exists. Right now, it exists. Not in your memory, not in a recording. In the actual structure of space-time, that event occupies a set of coordinates that are just as real as the coordinates of the moment you are experiencing right now. The block universe is not a metaphor. The mathematics of relativity treats all events symmetrically. There is no equation, no law, no physical principle that says past events are less real than present ones. And now we can return to the question of death and see it with genuinely different eyes. Because the moment of a person's death is, of course, a real event. It has space-time coordinates. It occupies a location in the block. But so does every other moment of that person's life. The morning they were born, the afternoon they learned to read, the evening they danced at a celebration, the quiet moment they sat in a garden and felt, for just a second, that everything was right. All of those moments exist, not existed, exist. In the past tense grammar of our intuition, yes, they are over. But in the geometry of space-time, they are simply located at different coordinates than the coordinates you currently occupy. The question of whether a person is gone is not a question the block universe answers with yes. The block universe, if anything, says that what we call gone is a consequence of the particular slice of space-time we happen to be moving through right now. And a different observer, moving at a different velocity, would draw their slice of now differently and would disagree about which events are in the past and which are in the future. If simultaneity is relative, then the distinction between what exists now and what is gone is also, in some profound sense, not absolute. This is not the same as saying that death is not real. The transition, the biological cessation, the change in the physical state of a body, all of that is real. It happens. It occupies its coordinates. But the picture of a person being erased, of their existence being undone, of the moments of their life being canceled, that picture does not match what relativity tells us about the structure of reality. There is a deeper layer here as well, and it comes from thinking about what the block universe means for our ordinary experience of time passing. If the block is fixed, if all moments are equally real, then what is the experience of time flowing? What is the sense that we are moving from moment to moment, that the present is moving, that time has a direction? This is genuinely one of the deepest unsolved problems in physics and philosophy. The block universe, as it stands, is symmetric in time. The equations of relativity do not prefer one direction of time over another. The arrow of time, the reason we remember the past but not the future, the reason we feel time moving forward rather than backward, is not explained by relativity alone. It requires thinking about entropy, about the thermodynamic arrow, about the extraordinarily low entropy state of the early universe that set up the conditions for time to feel like it has a direction. But notice what this means. The arrow of time, The thing that makes the past feel like the past and the future feel like it has not happened yet is not a feature of the geometry of space-time. It is a feature of our thermodynamic situation. It is, in a sense, a consequence of where we are in the history of the universe, not a consequence of the fundamental structure of time itself. And this makes the claim even more striking. The feeling that the past is gone, that the dead are absent, that moments are erased, is not a report on the geometry of reality. It is a report on the direction of entropy flow as experienced by a biological organism moving along a particular world line through a four-dimensional block. Einstein himself, near the end of his life, wrote a letter to the family of his lifelong friend Michel Besso, who had just died. And in that letter, he wrote that Besso had preceded him in parting from this strange world by a little. That does not mean anything, he said, for people like us who believe in physics know that the distinction between past, present, and future is only a stubbornly persistent illusion. These were not the words of a grieving man grasping for comfort. These were the words of a man who had spent his life understanding the structure of space and time, and who took his own theory seriously enough to apply it to the most personal and human of experiences. Now, it would be dishonest to stop there without acknowledging the complications, because there are serious physicists and philosophers who push back on the block universe interpretation. Some argue that quantum mechanics, which deals with the behavior of matter and energy at the smallest scales, introduces a fundamental indeterminacy that is difficult to square with a fixed, predetermined block. If the future is genuinely undetermined at the quantum level, if there is real, irreducible randomness in the universe, then the future coordinates of the block cannot all be already there. There are interpretations of quantum mechanics, like the many worlds interpretation, where the block still holds in some sense, but branches into different outcomes at each quantum event. There are others where the future is genuinely open. The full reconciliation between relativity and quantum mechanics is one of the great unfinished projects of physics. But here is what we can say with confidence. The intuitive picture of the past being simply gone, of existence being a brief spark that appears and then disappears into nothingness, is not supported by the physics of relativity. What relativity tells us, what Minkowski geometry tells us, what the Lorentz transformations tell us, is that the past has a reality that our intuition does not credit it with. The past is not a shadow. It is not a memory. It is not an echo. It is a part of the structure of the universe. There is something that happens when you really absorb this, not just intellectually, but in the way you hold the idea in your mind. It changes the texture of how you think about the people and moments that have passed through your life, not because it makes loss painless. Loss is painful, and the pain is real, and the pain makes sense, because we are organisms that navigate the world along a single world line, moving in a single direction through the block, and the coordinates we share with those we love become, over time, coordinates we no longer visit. The grief is real, the absence is experienced, but the absence is a feature of our trajectory, not a feature of reality itself. The moments are there. The conversations, the laughter, the particular way someone held their coffee cup in the morning, the sound of a voice saying your name, all of it occupies coordinates in space-time that are as permanent as the laws of physics themselves. The universe does not have an erase function. It does not take back what has happened. Every event that has ever occurred is a fixed point in the geometry of a universe that Einstein spent his life mapping. What relativity offers is not a denial of death. It offers a different geometry for thinking about existence, one in which what we call death is a transition, a change in state, a coordinate where one thing becomes another. But the life that preceded it, the full span of a person's existence in space-time, is not undone by that transition. It is simply located at earlier coordinates. And earlier coordinates in the block universe are not coordinates that have been canceled. They are coordinates that exist permanently in the structure of what is real. That is what the mathematics says. That is what Einstein's theory, taken seriously and followed carefully, leads to. And perhaps when we sit with that idea long enough, the word death begins to feel like a label for something that our intuition has always